Hello, students. Welcome to the review for Unit 3 of Geometry B, your second semester of your geometry course. We're going to be continuing with the formulas and concepts that we learned in last unit, but applying them to coordinate geometry, which gives us a lot of extra tools for calculating and envisioning the shapes and figures that we'll be studying. Now, there are three types of symmetry that you talked about in the first part of this unit. Point symmetry, meaning that you can rotate a figure around a certain point. So for instance, these figures in the top square rotating around this one point where the two lines intersect would eventually come to lie upon the other one in the exact same form. That is, before it's completely rotated. Line symmetry, however, exists if a line passes through any figure and splits that figure in exactly two pieces that folded upon each other would match up exactly. Plane symmetry is when, imagine a piece of sheet metal or something coming through, slicing through something and slicing it exactly in half. Now this obviously is a three-dimensional figure that would be sliced by a plane. Now, what kinds of figures have symmetry? Well, an equilateral triangle definitely has symmetry with respect to a line containing an altitude of that triangle. So what exactly would that look like? Well, if you had an equilateral triangle and drew a line from any of its vertices, and that line was an altitude to the opposite side, you can see that it splits this triangle exactly in half. However, a scalene triangle would have no lines of symmetry simply because it doesn't have any equal sides. So even if you split it as evenly as you could, it wouldn't be the same. What about a circle? Well, a circle has point symmetry, obviously, because there's a point at the center of the circle around which it can rotate, and it can rotate any number of degrees and still be symmetrical. What about a line? Well, I can draw an infinite number of lines through a circle, and it will split it in half as long as they go through the center of the circle. And it has plane symmetry. If a plane passed through it, it would be basically the same as a line. A parallelogram can have symmetry with respect to the point of intersection of its two diagonals. So if the parallelogram were, say, a square, then the two diagonals that pass through it would they would bisect each other, and they would create a point around which this square could rotate. And it would have four positions where it could land exactly on top of its pre-image. A trapezoid does not show symmetry unless it is isosceles. So try to imagine a trapezoid. It has a base on the top that is parallel to a base on the bottom, but it may or may not be an isosceles trapezoid. If it is, then the two sides that are not parallel are equal to each other and hit at the same angle. If that is the case, then it would have a line of symmetry passing exactly between it. So you can see that every point on the trapezoid is equidistant from this line of symmetry. Now, there are some very specific definitions about these types, and you'll need to be familiar with them, but you won't have to repeat them. First, a figure has symmetry with respect to a point, A, if for every point of the figure a partner point A prime exists such that A is the midpoint of A prime, A prime. So just think about that. If this was your point A, and this was your point A prime, once rotated 180 degrees, the point around which it was symmetrical is the midpoint between A and A prime. Secondly, a figure has symmetry with respect to a line if for every point A of the figure, a partner point A prime exists. We use our little trapezoid for an example, and A prime, where the line intersects the midpoint between those 2 points. So if we drew the line from A to A prime, the line of symmetry is the midpoint, passes through at the midpoint of that line. A figure has symmetry with respect to plane Z if for every point A of the figure, a partner point A prime exists such that Z is the perpendicular bisector of A prime. And you can kind of imagine that in my illustration here. All right, let's talk about the coordinate plane. It's divided into 4 equal quadrants. Of course, they go on forever, but they are split by the 2 axes, the X and the Y. The first quadrant is in the upper right corner, called quadrant 1, and it's always labeled with Roman numerals. Then counterclockwise to that would be quadrant 2, quadrant 3, and finally quadrant 4. The origin lies at the center of the intersection of the Y and X axis. You can see that there's a pattern for all of the points in each of the quadrants. Down here in quadrant C, for instance, all of the X values and the Y values will be negative. That's because when you plot a point, you start at the origin and you move left or right depending on whether the X is negative or positive. So if we were to plot point 0,6, I would not actually move left or right. I would stay right on the Y-axis. But the second point, the Y, tells you how far up or down to go, depending on if your point is positive or negative. And this one being 6 would take us right up to this spot up here. And this could be labeled 0, 6. Two formulas became very important as we were working with coordinate geometry. One is the distance formula and one is the midpoint formula. And these are written slightly differently than you see in your lessons. You might have seen this as x1 minus x2 and as y1 minus y2. And that'll make sense as we do one together. If you wanted to find the distance between point A and point B, you would take the 2 x values, the -4 and the +4, and put them into the formula. Now this formula may look familiar because it's based on the Pythagorean theorem. If you plot 2 points on a graph, you can easily make a triangle to join them with a hypotenuse, and you would find the distance between 2 of those points, square them, and then finally take the square root to find the hypotenuse. I'm going to switch to y's, 2 minus 2 squared. And that is the same as using the Pythagorean theorem to find the hypotenuse, which is what we're finding when we find the distance. Now to calculate this, -4 minus 4 is -8, and -8 squared is 64. 2 minus 2 is 0, 0 squared is 0, so this is simply the square root of 64, which equals 8. So the distance between these 2 points is 8 spaces. And you'll notice that they exist on a horizontal line, the line y equals 2. And the distance from -4 to the y-axis would be 4 spaces, and then 4 more to get to 4, 2. So it makes sense that the distance between them is 8. Here's another one, though, that would be a little different, but the process is the same. -6 minus -1 squared plus the difference of the y's, 7 minus -5 squared And of course, this square root is all the way across. 6 minus negative 1, remember, is the same as 6 plus 1. So this is 7 squared. Or, sorry, negative 6 plus 1, that would be negative 5. Negative 5 squared is 25. 7 minus negative 5 is the same as 7 plus 5, or 12, and 12 squared is 144. If I add them together, I end up with the square root of 169, which luckily is a perfect square, and that would equal 13. So the distance between these 2 points is 13 spaces. Now the midpoint formula is also based on the Pythagorean theorem, but what we're really doing is just finding the average between 2 points, because that will be the point in the middle. So if we were given the points negative 4, 2, and 8, 5, I'm just going to add up the x's. And remember, this also would be x1 and x2. And this would be y1 and y2. So I'm adding the x's, negative 4 plus 8. And then I'm going to divide that by 2. Remember, dividing by 2 is the same as multiplying by 1/2. Comma. And the y terms will be 2 plus 5. That will also be divided by 2. So the midpoint between these 2 points is, the first one was simplified to 2, and the second one to 7/2. So that is the midpoint between those two. And I'll let you try this other one on your own. Looks like it's going to turn out to be negative 1/2, negative 1/2. Okay, we talked a lot about slope. Remember, slope is the ratio of rise to run between any 2 points or on any line. There are some specific slopes that you need to know. A zero slope is a horizontal line. It's like driving across Kansas. There's no hills, there's no valleys. It's a zero slope. On the other hand, if you got to Colorado and hit a steep cliff, you'd find that your car would no longer be able to drive. This type of slope is undefined. A vertical line has an undefined slope. And you know that that's true because if you tried to calculate it, you would end up with 0, run. The rise would go on infinitely, but the run would be 0, and we can't divide by 0. That's why this slope is undefined. Most slopes are either positive, going upward from left to right, or negative, going downward from left to right. You can calculate this slope by counting it. If I plotted this point, negative 2, 3, I'd go 2 spaces to the left for negative 2 and 3 spaces up for 3. And the other point, negative 3, 1, I would go 3 spaces left for the negative 3 and 1 space up for the 1. These are the 2 points, and the slope between them is the ratio of rise to run. So starting with either one, I'm going to see how far I have to go up to get to the level of the other one, and I had to go 2 spaces. Then I had to travel 1 space to the right. So the ratio of rise to run is 2 to 1, or 2. And if I were to draw a line between these points, it would continue with a slope of 2 until the line ended. We'll do a little calculation of slope in the next slide. If you don't have a coordinate plane, or you want to figure out the slope algebraically, there is a formula, and it subtracts the y values, which would give you the measurement of the rise, and it puts that in a ratio over the difference of the x values. So let's try it out with a couple of these problems. Here I've got -4 and 5. It doesn't matter which order you do these in as long as you're consistent. So -4 minus 5 over the x terms, 2 minus 3. Oh, hang on a minute. This is asking a different question. It says indicate the equation of the line through to -4 and having a slope of 3/5. So we already know the slope. Hang on to that thought about calculating slope, and I'll bring it up in the next problem. Okay, so let's see if we can draw this one on the board. I'm going to plot point to -4 by moving 2 spaces to the right and 4 spaces down. And then I'm going to calculate the slope by going rise to run up 3 and over 5. 1, 2, 3, 4, 5. So the line containing this point and this slope is this line. Now, does this help me calculate the equation? Well, I'm going to show you a skeleton equation that is linear. It's y equals mx plus b. By now, this should look familiar to you. The x and y are the values of any point on the line, but the m is the slope and the b is the y-intercept. I know the slope is 3/5, so I can automatically put that in, but I don't know the y-intercept. And I would like to say it's going to be close to 5. However, it's not quite 5. So let's see if we can figure it out another way. Since we have a point and every point must make the equation true, let's use the y value as our y and the x value as our x and see if we can calculate the y-intercept b. 3/5 times 2 is 7/5, and subtracting 7/5 from 4 means that we have to change -4 to -25, because of course you have to have a common denominator to subtract fractions. -20 minus 7, oops, 3/5 times 2 is actually 6/5. So let me correct that. Correct it here. So together that would equal -26/5. -26/5 is just a little bit more than 5. So that's why my line is going a little bit beyond the 5. So to rewrite this whole thing, I would go back to my y and x, but I would replace the slope with the 3/5 and the y-intercept with -26/5. Now, this equation can be written in several different forms, and you are usually instructed as to the form that you're supposed to leave it in. This one is called slope-intercept form. If I multiplied everything by 5, that would get rid of the fractions. 5y equals 3x minus 26. And I could even move this so that the x and y terms are on one side and the number on the other for standard form. And depending on the form that you're asked for, make sure that your answer is in that form. Now this one, the second question, wants me to write the equation, but it only gives me 2 points. And it says that the perpendicular bisector is the line that I'm trying to draw. So let's go ahead and plot this one. I'm going to go over to 4 and up to 1 for my first point, over to 2 and down to 5 for my second point. And I'm going to go ahead and draw this line between the two, even though this isn't the line that they're asking us for the equation of. They're asking us for an equation of a line that is the perpendicular bisector of this line. And not only that, we don't know what the slope of it is, and we don't know any points on that line. However, we can calculate the slope of this line, and there is a relationship between the two. So I can either count it or I can calculate it using my formula. So why don't I just count it? 1, 2, 3, 4, 5, 6 is the rise. 2 is the run. So the ratio is 6 over 2. Or that can be reduced to 3. Now, if I know the slope of a line, I know the slope of a line perpendicular to it is the negative reciprocal of that line. So the slope of the line that I'm trying to find is going to be negative 1/3. The reciprocal is 3 upside down, which is 1/3. And the negative of that obviously just has a negative sign. So y equals negative 1/3 x plus b. Now at least I have the slope, but I don't have any points on this line. I know that it's going to be going through somewhere around here because it's going to bisect that line. To find the midpoint would give me all the information I need to find the midpoint. So 4 plus 2 is 6 over 2 would be the midpoint's x term. And 1 plus negative 5 is negative 4 over 2 would be the y term. So simplified, that would be 3 comma negative 2. So over to 3 and down to negative 2, right there is the point of intersection. And because I know the slope is going to be 1/3, negative slope forces me to go down instead of up and then over to the right. So another point on this line would be here and here. So drawing this line, and I'll use a different color, should be the line that is the perpendicular bisector of the first one, and it does look like it is. Now, where does that go through the y-axis? I can see that it's going through at -1, but maybe I'm not sure. Maybe my graph is pretty messy and I'm not sure. So I can always use that same technique I used before by putting in -2 for y and 3 for x and calculating it. -3, whoops, I forgot to put the 3 in, okay. Put some parentheses around it. -1/3 times 3 is -1. If I add that to both sides, I end up with -1 being b. So right there, it is confirmed that it goes through the y-axis at -1. So I can rewrite my equation as y equals -1/3 x minus 1. All right, now what about this one? If the point a, 7 lies on the graph of the equation 5x minus y equals 8, then what does a equal? Well, this one I don't need to graph. This one I'm just going to calculate. I don't know x, but I'm going to call it a, but I do know y, and I know it's going to equal 8. So all I have to do is use some algebra by adding 7 to both sides. I get 5a equals 15. And by dividing both sides by 5, I get a equals 3. So the point 3, 7 lies on the line that this equation represents. Okay, let me clear some space off of this from my previous presentation. The slope of a line that is perpendicular to a line whose slope is -2/7. Well, remember we said if it's perpendicular, the slope will turn upside down and change signs. The negative reciprocal of this would be 7/2. The equation of the line through point -50 and parallel to the y-axis. Well, the y-axis is the one with the no slope. Anything that's vertical has the form x equals some number. And since x equals -5 in this point, the line equation will be x equals -5. What is the relationship between 3a plus 2x minus 9 equals 0 and 12y plus 8x minus 5 equals 0? Well, I have a feeling they're going to be either perpendicular or parallel since it's on this section of the review. So I'm going to simplify these and put them in the form that creates the slope for me. So instead of 3y plus 2x, I'm going to subtract the 2x from both sides, and I'm going to add the 9 to both sides, rewrite that equation in slope-intercept form by dividing both by 3. So negative 2/3 x, and 9 divided by 3 is 3. So this reveals the slope to me is negative 2/3, because remember the formula is y equals mx plus b, where m is the slope. Now let's try that technique on this one. 12y equals negative 8x plus 5. Dividing both sides by 12, I get y equals negative 8 divided by 4 would be negative 2/3 x plus 5/12. So as it turns out, they both have the identical slope, and if two lines have an identical slope, they are parallel to each other. They will never intersect because their slope is the same. So these two are parallel. All right. We can see circles on coordinate planes as well, because a circle is defined as all of the points that are equidistant from a single point. There's a special formula, however, for circles, and it is like this. X minus, I believe it's called A, which is the x coordinate of the center of the circle, squared, plus y minus b, which is the y coordinate of the center of the circle, equals radius squared. So if you know the center of the circle and the radius, you can write the equation of the line. But if you had a question like this that says, if the equation of the circle is x plus 4 squared plus y minus 6 squared equals 25, the center point is what? Well, I know I had to subtract it to get plus 4, so it would be negative 4 and 6. That's the center of the circle. If the equation of the circle is, and it gives the same equation, then the radius is what? Well, if 25 equals r squared, then r must be the square root of 25, or 5. If the equation of a circle is x minus 2 squared plus y minus 6 squared equals 4, does it pass through point 5,6? Well, we can easily figure that out by putting this into the formula. 5 minus 2 squared plus 6 minus 6 squared. I can see that 6 minus 6 will be 0, so whatever my initial value is going to reveal. 5 minus 2 is 3, and 3 squared is 9. 9 plus 0 is not equal to 4, so this point does not lie on the circle. The equation of a circle having a diameter with endpoints negative 2, 1, and 6, 7 is what? Well, let's plot that out. Negative 2, 1 would be right here on my graph. And 6, 7, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 would be right there. And these are the endpoints of the diameter of a circle. So, what can we find out from this line? Well, we can definitely find out the radius. First, we'll have to calculate the distance of this line, and then we'll have to calculate the midpoint. So the distance between these 2 points, we'll use our old friendly formula, square root of -2 minus 6 squared plus 1 minus 7 squared. -2 minus 6 is -8 squared is 64. And -1 minus 7 is -6, and that squared is 36. 64 plus 36 equals 100. And the square root of 100 is 10. So the diameter equals 10, but that means the radius equals 5. Okay, so I've got one part. Now, do I know the center of the circle? No, but I do know that it's the midpoint of this line, so it's going to be someplace right around here. I'm going to take the 2 points and average the x's. -2 plus 6 is 4 over 2. 1 plus 7 is 8 over 2. So the midpoint is 2, 4. Now I can set up my formula. X minus 2 squared plus y minus 4 squared equals the radius squared, and the radius is 25, or the radius is 5, so the radius squared will be 25. So this is the equation for this circle. X minus 2 plus y minus 4 squared equals 25. And either one of these points should work. We could try them out. -2 minus 2 is -4. 4 squared is 16. 1 minus 4 is -3. -3 squared is 9. If I add 16 plus 9, I really do get 25. So a lot of figuring out, but very good information. Now, you had quite a few figures and proofs, and when you're talking about coordinate geometry, it's a little bit easier to see how the proofs work. On your test, you have a question that says, in the figure, M and N are midpoints of RT and ST. What is the length of MN? Well, one of the theorems that you learned is the connecting line between the midpoints is called the median, and that distance is half of the distance of the longer line below it. So it's going to cut the width of this triangle in half. So what is the distance between 2A0 and 2B0? Well, according to our distance formula, 2A minus 2B squared plus 0 minus 0 squared will be the square root of the distance. So we need half of that. Well, 2A minus 2B would be 2 times A minus B, and that's all squared. But the other part is 0, right? Well, to find the square root of something that's squared, it's going to undo the square root, and it will be 2 times A minus B. So the distance between those 2 points is 2 times A minus B. If we want half of that, we'll just remove the 2, and the distance of MN equals A minus B. Now, what about this problem? All xy such that -2 it looks like part of this problem is missing. So let's look at the illustration. -1 is less than or equal to x is less than or equal to 3. So they want us to graph this. This is a bit of an inequality. So some of the rules that you need to know is if your x is between -1 and 3, then it could be anything in the shaded area. Because these inequality signs have an equal portion, the line that's drawn between the true part and the not true part are going to be solid lines. And because there's a limit on each side, there are going to be 2 lines, and the area between them is going to be shaded. Finally, write an equation for ML. A lot of information is given here. It says ML is parallel to the x-axis. Therefore, finding the y-coordinate of point M or L will determine the equation of line M. So you're given a lot of information, but you can see that it's on a graph, which is very convenient. And it's at the point where y equals 3. Because it is a vertical line, we know that the format of the equation will simply be y equals 3, because remember the slope is 0 of a horizontal line. So ML is parallel to the x-axis, therefore finding the y-coordinate of M or L will determine the equation of line M. That's true. To determine the coordinates of M, first determine the coordinates of R and S. Since they are midpoints of EC and EA respectively, R, which is 1, 5, and S, which is -3, 1. So let's see where R is right here, and S is right here. Since M is the midpoint of RS, the y-coordinate for M is 3. How do we know that? We add up the 5 plus 1, 6, and divide by 2, so it's 3. Therefore, the equation of ML is y equals 3. So if you didn't have the picture, you could still calculate it. But because they put this on a graph for you, you already know that ML lies on line y equals 3. All right. Now that brings us to the end of our review. And I know I went over a lot of information fairly quickly, but if you still have questions, please just write them down. Let me know when you call to get credit for this assignment, and we can go over those. If you feel like you want to see more examples of any of these types of problems, then just let me know at that time. I can open up my classroom or we can talk them through. If you don't have any questions, good for you. I hope you have some of these things in your notes, and I just want to wish you good luck on the quiz.